Welcome back to another electro-technology video, and today I have a power tool that is no longer working. So we're going to have a look and see if we can't fix it and get it working again. I have with me a tile cutter, and this tile cutter is not working. So if I plug it in, I turn it on, what should happen is when I press the on button, which is down here, it should fire up. And nothing is actually working. So what that means is, for some reason, there is no voltage or current flowing through this cable and actually to the saw. So to find out exactly what's wrong with it so I can actually fix it, there's a few things I have to go through, a few steps. And the first step is actually I need to do a visual inspection, because maybe there's something really obvious here that could be causing me the problem. So I would start with my cable. This looks all pretty good. There's nothing wrong with that. It's a little bit dirty, but other than that, there's nothing wrong with it. It goes through this isolating component here. It's kind of like a surge protector. And it looks, for all intents and purposes, like it's okay. This may not be the case, but we'll continue on. So if I check the rest of the cable, there's a bit of a knot in that cable there. And if I go down to where the cable actually enters into the device itself, I can actually notice that the part that holds the cable in place has actually come loose. So that could potentially be causing some problems with connection to the wiring inside this unit. Realistically, if you've got any problem like this where you have a device that just won't fire up for whatever reason, 9 times out of 10, your problem is going to be in this cable somewhere. So what we need to do is we need to take this cable out, or open this up so we can get to the cable section and test continuity, which means we can check to see whether there is any break in any of the cores of the cable from here to there. If our continuity is correct and we have no problems at all, then the issue may be in the motor that makes this thing spin. But 9 times out of 10, it's going to be a problem here with this cabling. I'm suspecting the problem might be here or at the point of entry. So let's pull this apart and let's go through those testing procedures and see what happens. Okie-dokie. So the first thing I have to do is I actually have to figure out how to get to the cable, which is underneath here. It goes in through this part. Now, I've never taken this apart before, and looking at it, it looks like I can see some seams along here around this plastic part where it looks like there must be a way for this to come off. Alternatively, there possibly is a way to come in from the top. When you're doing this kind of work, if you've got a diagram, it's going to make your life much, much easier. If you don't have a diagram, it really is kind of trial and error. Take off a couple of screws here, take off a couple of bolts there, and see what moves. Being mindful that sometimes in devices like this, you might have a motor, and there is definitely a motor in here, that could be bolted to the housing. So you want to be careful what you undo, because you don't want to undo anything that's already inside and you still haven't figured out how to get the thing apart. It has to come apart somehow because it had to be built in the first place. So it's just a matter of finding which screws and which bolts loosen it off. So that's what I'm going to do right now. I'm going to get some tools and I'm going to go through and figure out which ones I need to get apart. So I started with the top, and the reason I did that was because when I was looking at where this cable goes in, I could see that it was feeding towards the top of this unit. So I thought, well, you know, what better way? There's definitely some screws here. I can take a lid off it, and I've done that, and now there we go. I actually have some screws here and some screws here. which will allow me to get to the electronics. This one here is covering the switch on this side, and this is covering the motor. So, knowing how a circuit works, your cabling has to go to the switch first. So I'm going to take this off, have a look, see what's going on here, and then if need be, I'll take that off as well. Okay, that didn't quite help me actually. The problem with that is here I can see the switching mechanism, but it looks like this is literally just a drainage point in case water gets in here for some reason. So I'm going to have to put this cover back on and have a look at getting behind here. Okay, so I've got this apart. This is where the actual motor is mounted. And again, as I suspected, my cabling is in here. It's actually not in this compartment either. So I have to figure out how to get this bottom piece off. And I have found 2 screws here and 2 screws over there, which I suspect hold that part on. So if I undo that, hopefully that bottom piece will come out and we can have a look. So that's what we're going to try next. We'll put this back and then here we go. A lot of times when you're doing this kind of work, pulling things apart, and you come across these screws that are heavily recessed. So for example, if I put my screwdriver in, that goes, a fair way down. A lot of times you kind of just got to feel around because you're not going to be able to see the screw to actually get the screwdriver in correctly. So you really have to just kind of feel around until you get it right, and then you can start undoing it. So I've got those 4 screws off. Let's see what happens when I try lifting it up. Success! Yes, the bottom is now coming apart. So I'm going to tip this up and hopefully get that apart. Always being mindful of the cable, that you don't squash the cable as you're moving things around, especially larger items. Now what I'm doing here is this shroud, if you like, that holds a cable in, can actually loosen off. So I'm actually doing that. I'm going to loosen that off so then I can slide this cable in a little bit better, and that way I can get this off properly without having to disconnect the cable altogether, because I don't want to do that. I want to check this cable. If this cable's okay, then I've got to look at something else. Okay, here we go. I've got this apart, and now what I'm going to do is I'm going to get my multimeter out and I'm going to test the cable. We're going to put a probe on one end and a probe at the other end, and hopefully it should tell us if there's continuity or not. So let's get our multimeter out and we'll do that. While I'm putting this together, please also keep in mind, try not to lose any of the screws. Now, when I've taken this apart, I know that the screws are now sitting underneath, they've actually dropped out. So I've just got to be aware that they're actually there, and I'll collect them in just a moment, because if you're out on a job site, for example, you don't have the luxury of being able to spread out and work around nice and neatly like I am here in the workshop. If you're out on the job site, it's very easy to bump something, a screw falls down a step, or, and then you're really in trouble because you can't put it back together again. So please always keep in mind, make sure you're checking where your screws are, if they're falling out or whatever the case may be. So I will just lift this up. There we go. All 4 screws accounted for. Excellent. All right. Okay, so I have my cable comes down through here. There's that little lock nut that had come off, and it goes through a clamp, and then the wires come out here and then through to the switch on this side. So all I'm going to do is I'm going to test between this point and the corresponding point on the plug, and that should show me whether there's continuity or not. And I'm expecting there not to be any continuity because obviously it's not working. So this is probably causing me some issues. Alternatively, there is an issue where it could have been caused down here where the cable actually clamps in. Because where it clamps in, it's clamped fairly tight, and that could potentially also break the cause of the cabling. So I won't really know unless I cut this back. I'm not going to actually know whether that's the case. So it's really going to kind of be a 50-50 here, whether this is causing problems or not. Now I can actually check this because I can take this off, and if I take this off here, which is what I'll probably do, and I'll test from this side onwards between there and there, that'll tell me whether this thing is being faulty or whether it's actually that clamp in there that's causing the problem. So let's pull this apart, get this ready, and we'll test. Okay, with my multimeter, I'm going to put it onto my continuity testing option, which is down here. Now, once I put this onto continuity, what should happen is when I put my 2 probes together, it should beep. Now, I'll be honest, my multimeter is actually playing up a little bit, and it won't do that. It'll beep and it'll get stuck. So what I'm going to do is I'm going to leave it on this setting. I set that up properly there. And when I put my probes together, you should see the values change, and I should be looking at almost 0. So 0.2, 0.1, that's close enough for 0 for me. That tells me that there's continuity. If I take that off, it'll go back to that. So that's what I'm going to use rather than the actual beeping sound itself. So I'm going to choose the neutral wire, the blue wire first. Yes, I have a value there, so that tells me that wire is perfectly fine. The next one is the active wire. This is going to be a bit awkward. Got to get the sleeve off the back wire there. There we go. Active to active. And that's looking good too. So that now tells me that this cabling all the way through here is pretty good. If I move this one around, and this is something you really must do, because of that clamp could be causing my problem, if I give it a bit of a tug and a bit of a move around, and then I put my meter back on it, if that was to be the problem, then I'd probably see the fault appear. But in this case, the fault hasn't appeared. It's all looking good. Now, you notice I haven't tested the earth. The earth in this case isn't going to matter. The earth is literally only there for protection, and this would run without the earth cabling. So these are the 2 cables I need to check, my neutral and my active. They are working perfectly fine, which now tells me, without a doubt, the problem is in this unit here. So, how do I fix it? Well, in this case, I'd probably need to replace this unit itself. Alternatively, I can take it out of the circuit. So now I have identified the problem. It is actually this safety device here. When I'm out, I'm going to take this out of the circuit altogether. I'm just going to cut this off, put a new plug on, because when I'm working on the job site, I'm going to have something like this anyway, which already has it inbuilt. Or I might also have, I have a little orange box which has safety devices on it as well. Anytime I'm working out on the job site and I'm using power tools, I'm always going to have that extra level of protection. So this for me is really redundant. I don't need this because I'm going to be using it elsewhere. So I'm going to cut this off and I'm going to put a 3-pin plug on the end of this cable. So I'm going to go through the process of doing that now. Okay, to do a 3-pin plug, what is required is obviously the plug, and I have to strip this cable back far enough so that it can go into the plug and not be too long and not come out. I also need to make sure I get the right cores on the right pin, otherwise I can end up in a bit of trouble. So to do this, the very first thing I'm going to do is I'm going to take the outer sheath and the lock ring, and I'm going to put the lock ring through and the outer sheath. I'm going to slide that down. So that's on. It's out of the way now, because there's nothing worse than getting this all prepared, putting it together, and then realize you forgot to put the outer covering on. So if I put that on first, slide it down out of my way, I know that I'm good to go. So now all I need to do is cut this cable. I'm going to use my retractable knife to do this, not my pliers. And I'm going to basically go around this cable, strip it back, and then terminate. All good. Now, depending on the brand of plug that you buy, a lot of times they'll actually have a guide. This one's got a guide that shows you how long to strip the cabling back. You will find you'll do this quite often in your job, and you'll get to the point where you'll just know how long to do it. You won't actually need to use this anymore. But in case you forget, it is there. The guide shows you how much to strip back on. So let's do that. So when I do this, I want to make sure that I don't cut the inner cores of this cable. I just want to take the outer sheathing off. So if I was to use my guide, there we go, my guide says I should be cutting off about there. And I take my retractable knife and I just score the outer insulation. I actually don't want to cut all the way through. So if I bring that in, you can see when I fold this over now, you can actually see it should start pulling apart, and that's what I want it to do. So that way I'm not cutting into the inner insulation. And then I just basically work my way around, and it should just all come apart. Once I've done that, I can then pull that apart. There we go. I now have my inner cores, which I can strip and terminate as I would normally do with my pliers. Now this cabling, depending on the type you're using, sometimes it can be a little bit easier, sometimes it can be a little bit harder to strip. You'll notice that I'm doing this really easily. It's very, very soft, so I don't have to put a lot of effort into that. Once I have this stripped, I then obviously want to twist this. Again, these are very easy. I can just twist these with my fingers, get them into the right shape, and then I will just tighten them up with my pliers. There we go. Like that. Now, when I take my 3-pin plug, and this is the important part, what I need to do is I need to put the cores into the correct terminal. And then, when I put them in, I have to put them in here, screw them down, and fold them around so they come back up this way here. That way it locks them in. So if there's any pull on the cable, these wires aren't going to come out. They're literally going to be tied around this plug mechanism here. Okay, so that's on, and now I fold these over like that. And what should happen is they should all line up quite nice and neatly. There we go. And now I can slide the outer sheath on, and that's it, done. Now to get this on, you have to put your screwdriver down and through there, and you have to kind of just lever it on. And it can be a little bit time consuming and can be a little bit hard the first time you do it, but that's how you have to get them on. And I'm actually using the wrong screwdriver for this. This is too big, so I'm going to get a small one and make my life a little bit easier. There we go. Plug is on. All I need to do is put the lock ring on, and that is ready to go. Okay, I have put the lock ring on nice and tight. This plug is ready to go. Before I start putting this back together though, I must test it. It is so important. There is nothing worse than finishing a job, thinking you're done, putting everything back together, and then flicking that switch only to find out it doesn't work, because then you've got to pull it all apart again and you look like an idiot. And we don't want to look like idiots because we're learning to be professionals. So how do we test it? Exactly the same way I tested to see if it was broken in the first place. I grabbed my multimeter and I put it onto my continuity testing option. And again, I'm just going to go across my pins and make sure it's all good. Making sure my cable inside there is not twisted. My cable inside my plug there is looking a little twisted, and that's just because when I put this lock ring on, this has twisted around. So I'll tidy that up a little bit in a moment. I just want to make sure it's actually working correctly first. So one probe on my neutral. One probe on my neutral. Yep, that's looking fantastic. Probe on my active. Probe on my active. Perfect. Yes, my multimeter tells me this is going to work. So now I'm just going to tidy this up, put it all back together, then we'll plug it in and see if it turns on. At the same time as putting this back together, I'm going to put this lock ring back on so this whole thing holds together properly as well. There we go, all back together. And you're probably wondering, why did I not use a battery drill to take all these screws in and out, instead of just using a normal screwdriver? And the reason is because this is all made out of plastic. And if you use a battery drill, you will run the risk of threading or stripping the plastic where the screws actually bite into, and then it's no good. So where you've got any soft material, so plastics, maybe other sorts of plasterboards or any other soft material you might be working with, always use your hand tools. Don't use a battery drill. It will cause more damage than it's worth. Okay, so this is all back together. I'm just going to make sure everything lines up. This doesn't line up properly. There we go, it does now. sometimes you'll need to give things just a little bit of a push. When you are putting stuff back together, always keep checking to make sure things are lining up, because again, you don't want to find things that aren't sitting correctly and then they just don't match up when you finally finish the job. So let's plug this in and let's see if this works. Fantastic, it is working. There you go. That is how you fix a power tool. Now, this particular power tool was a little bit more complicated than others. If you've got just maybe an angle grinder or a drill or something like that, the process is a little bit easier than this. But this can save you a lot of money. So for example, I actually need this for a job tomorrow. And if I had not inspected my gear before the job, and this is why planning is always so important for us electricians, always plan out your jobs before and check your equipment, make sure your equipment is working. If I had checked this tomorrow morning, I would have been in all sorts of trouble, because then it's like, well, it's not working, I've got to fix it. I don't have time tomorrow morning to fix it. I have to get onto the job. So I can't delay the job, which means I would have to then go out and buy a brand new one on my way to the job, so I didn't lose any time, do the work, and then come back and fix this one later on. And that's money that I would lose, time and money. So by preparing the day before, knowing the jobs I've got coming up, checking all my equipment, if I come across a problem like this, I can actually then go and repair it. So I hope you have enjoyed this video. I hope you've got something from it, and obviously I hope you've learnt something from this video. And if so, please like and subscribe, and I'll see you next time. Awesome.